Hey everyone, welcome back to the channel. In the last video, we learned how to place chess pieces on the board using JavaScript. If you missed it, be sure to check it out. Today, we're diving into the logic behind how pawns move in chess, from basic forward moves to capturing diagonally. Let's get into it. First, let's take a quick look at how chessboard coordinates work. When a piece moves downward on the board, the x-axis increases. When it moves upward, the x-axis decreases. If the piece moves to the left, the y-axis decreases. And when it moves to the right, the y-axis increases. We already have our chessboard and pieces set up in HTML, CSS, and JavaScript. If you're starting here, make sure you've seen the placement video or grab the code from the description below. Now, let's add an event listener to each chess box so we can detect exactly where the player clicks. This way, we can track which square was selected, and that's our first step toward handling pawn movement. Once we detect which chess square was clicked, we need to check if that square is empty. We can do this by checking if the square contains an image element, since every piece on the board is represented by an image. If there's no image, it means the square is empty. If we find a piece on the clicked square, we'll extract some useful information from it. This includes the square's position on the board, its x and y coordinates, along with the piece's color and its type, like whether it's a white pawn or a black bishop. This information is crucial for handling movement rules correctly. After that, we'll check if the clicked chess box contains a pawn. This step is important because we only want to trigger pawn-specific logic if the selected piece is actually a pawn. To keep our code clean and organized, we'll create a pawn handler function. This function will take care of everything related to pawn movement. We'll pass it the x and y coordinates of the clicked square, the color of the piece, and its name, so it knows exactly what to do next. Inside the pawn handler, we've created a variable called selected. This variable stores all the important information about the selected piece, its x and y coordinates, its color, and its name. It basically helps us keep track of which piece the player has chosen. Next, we check if the pawn is in its starting position. For white pawns, that means the x-axis is at 2, and for black pawns, it's at 7. This is important because pawns can move 2 steps forward only from their starting row. If the white pawn is on its starting square, we use a for loop to calculate the 2 squares it can move to. Since it's allowed to move 1 or 2 steps forward from the start, the loop helps us check both possible moves. Inside the loop, we create a variable called temp chess box to represent the squares in front of the pawn, basically the next 1 or 2 chess boxes it could move to. Before allowing the pawn to move, we add a condition to check if the temp chess box is empty. Pawns can't move forward if there's another piece in the way, so we need to make sure no image element exists in that square. If there's no piece blocking the way, we add a CSS class called nextSelected to that chess box. This gives it a border or highlight, so the player can clearly see that it's a valid move and know exactly where the pawn is allowed to go. For black pawns, we use the same logic, but we tweak the direction. Since black pawns move downward on the board, we set up the for loop to increase the x-axis value instead of decreasing it. This way, we correctly calculate the next 1 or 2 squares in front of the black pawn, and apply the same checks for valid movement. Now let's add logic for when the pawn is not on its starting square. In this case, it should only be allowed to move 1 step forward, not 2. If the piece is a white pawn and it's not on its starting square, we simply decrease the x-axis by 1 to check the next square in front. If that square is empty, we add the next selected class, just like before, to highlight it as a valid move. Oops, I almost forgot. We need to actually style the next selected class in our CSS. Let's add a border to it, so the highlighted squares stand out visually on the chessboard. If the pawn is black and not on its starting square, we apply the same logic, but this time we increase the x-axis by 1, since black pawns move downward on the board. Now let's handle pawn captures for white pawns. We use a for loop to check the 2 diagonal squares in front of the pawn, one to the left and one to the right. These are the only directions a pawn can capture. In the loop, we decrease the x-axis by 1 and adjust the y-axis by +1 and -1, using a variable n to control the direction. In each diagonal square, we first check if there's a piece present by looking for an image element. If there is, we extract its ID to identify its color. Then we compare it with the color of the current pawn. Pawns aren't allowed to capture pieces of the same color, so we only highlight that square with the next selected class if the colors don't match. This prevents players from accidentally capturing their own pieces and ensures the capture logic follows real chess rules. After checking one diagonal direction, we toggle the value of n. If n is 1, we change it to -1, and if it's -1, we switch it back to 1. This allows us to check both the left and right diagonals for potential captures. For black pawns, capturing works the same way, but since they move in the opposite direction, we increase the x-axis instead of decreasing it. Everything else stays the same. We check both diagonals using the variable n, look for enemy pieces, and highlight valid captures using the next selected class. This keeps the logic consistent while respecting the direction each color moves on the board. To keep our interface clean and avoid any misclicks, we build a cleaner function that goes through all the chess boxes and removes the next selected class. This way, every time a player clicks on a piece, any old highlights from previous moves are cleared first. It's a simple step, but really important for maintaining smooth and accurate gameplay. We call the cleaner function every time a chess box is clicked. This clears any previously highlighted squares, making sure only the valid moves for the currently selected piece are shown. Now, let's create a piece mover function that moves a piece to the clicked chess box. Keep in mind, this function will only place the piece in the new square. It doesn't yet handle removing or clearing the piece from its previous position. Inside the piece mover function, we first create a new image element for the piece. We assign it an ID based on the selected piece and set its src attribute to the correct image depending on the piece's color. Then, we select the clicked chess box using its ID, which we pass into the function as a parameter and append the image element to that square, visually moving the piece there. First, we create a variable to store the clicked chess box element itself. Then, we create another variable called chessBoxChild to hold any child element inside that box, like a piece image, so we can check or manipulate it later. We create a for loop that runs based on the length of the elements with a certain class. Inside the loop, we check if each chess box does not have the next selected class, so we can identify squares that aren't currently highlighted as valid moves. If the clicked chess box has the next selected class, we first check if it contains a child element, like a piece. Then, we retrieve the X and Y coordinates and store them in piece ID. After that, we call the cleaner function to remove all highlights and then call the piece mover function, passing the piece ID to move the piece to the new square. If the clicked chess box doesn't contain an image element, that means it's an empty square, a valid move without a capture. So we simply call the clean selected boxes function to clear all highlights, and then we call piece mover with the piece ID to move the selected piece into that empty square. After moving a piece to its new location, we still have the original one sitting on the board, which isn't how chess works. So we create a piece remove function that targets the old chess box based on the selected piece's coordinates, finds the image element inside, and removes it. This completes the move visually and keeps the board accurate, just like in a real game. That's it for this video. Right now, pawns can move across the board, but they don't eliminate opposing pieces just yet. We'll be building the piece eliminate function in the next video to handle captures. Thanks for watching, stay tuned, and keep following this awesome chess series.